Let us add the polynomials 2x square plus 3x minus 5 and 5x square minus 4x plus 7. Before we start, we first need to check if the polynomials are written in their standard form. Now, what is the standard form of polynomials? The two polynomials that we have over here are of degree 2. So, let us look at the standard form of a polynomial of degree 2. It is ax square plus bx plus c. In the standard form, the terms are written in the decreasing order of the power of their variable. So, the first term we have x square, in the second term we have x raised to power 1, and in the third term we have x raised to power 0, which is 1. So, c into 1, c, that is the constant. And similarly, for a polynomial of degree 3, the standard form is ax cube plus bx square plus cx plus d. Now, this polynomial is written in the standard form. And same goes for this polynomial. We have x square, then a term with x, then a constant. So, we are good to go. Now, if you just recall, whenever we used to just add the numerals, we would place them vertically like this. And the ones digit was in one column, the tens digit in a separate column, and the hundreds digit in a separate column. We are going to do the same thing with these polynomials now. And this is called adding the polynomials using the column method. So, the first step is clear and we have checked it. The polynomials are in the standard form. The second step is to place the polynomials in a vertical arrangement with the like terms placed one above the other. What are like terms? The terms which have same variable raised to the same power. 2x square and 5x square are like terms. Similarly, 3x and negative 4x are the like terms. So, let us write the first polynomial, and for the second polynomial, we will place 5x square just below 2x square, negative 4x just below 3x, and 7, the constant below the constant. Now, the third step is to check if any power term is missing in any polynomial. If that is the case, we write a 0 as its coefficient to avoid the confusion in the column-wise arrangement. What it is saying is, if any term was missing in this polynomial, for example, if negative 4x was not there, we would place a 0x in its place. Okay? And then we will just perform the addition. So, let's do that. Since these are like terms, okay, let's just keep x square as common, and the coefficient would be, we add the numerals 2 plus 5. Both are positive, we added them. Then we put a plus sign, and again we place x, and now the coefficients are plus 3 and minus 4. So, we add plus 3 and minus 4. Same goes for the constant, which is minus 5 plus 7. Now, 2 plus 5 is 7x square plus 3 minus 4 is minus 1x plus 7 minus 5 is 2. So, we get 7x square. Now, plus minus is minus. So, we have minus x plus 2, and that is our final answer. Let us look at one more example. Now, the first step is to check if the polynomials are in standard form. So, the first polynomial here is not in standard form. Its degree is 3. So, this term should be placed in the first place. So, 5x cube, then we will have negative 6x square, then negative 4x and plus 2. This one is already in its standard form. It is in the decreasing order of the degree of the power of the variable. Now, let's just write down in these polynomials in the vertical arrangement. So, here we have the first polynomial in the standard form. Then, for the second polynomial, we have minus 3x cube. So, this will be placed just below 5x cube. Okay. Then, we have 2x. We will place it here, just below minus 4x. And then, we have minus 11, which will place here. Now, look at the third step. This will make more sense in this example now. The term which is missing. In the second polynomial, there is no term of x square. So, what we can do is we can just write plus 0x square. Since 0 into x square is 0, so we are just adding 0. We aren't making any change in the polynomial. Since this becomes easy to calculate now, let us do the addition. Let's take x cube as common, and then we have plus 5 minus 3 plus, let's take x square as common, and for the coefficient we have minus 6 plus 0. Similarly, let's take x, and then we have minus 4 plus 2. And lastly, for the constant we have 2 minus 11. So this is 2x cube minus 6x square plus minus 4 plus 2, minus 2x plus 2 minus 11 is minus 9. So 2x cube plus minus is minus, minus 6x square, again plus minus is minus, minus 2x. Similarly, plus minus is minus, so minus 9, our final answer. Now let us do this addition where we have 3 polynomials. Now we won't rewrite the steps, we are already very much familiar with it. So let's just check if these are in the standard form. Well, the first one is not, so let's place it, write it in the standard form. 4x cube minus 3x square plus 8x plus 4. The second one is in the standard form, and so is the third one. Let's write down the first polynomial. Now comes the second polynomial. We have 3x cube, which will place here. Then we have negative 4x, which will place here. Then we have positive 7. Okay. For the third polynomial, we have 7x cube. Let's place it just beneath 3x cube. Then we have minus 2x square. So this is the column for x square. So we'll place minus 2x square here. Then we have plus 9. So we'll place it over here. Now we'll just fill all the terms which are missing with 0. So this will be plus 0x square and this will be plus 0x. Now let's add them. So we have x cube as common. The coefficient is 4 plus 3 plus 7. Plus, then we have x square and the coefficients are minus 3 plus 0 minus 2. We can just write minus 3 minus 2. Plus, then we have x and the coefficients are 8 minus 4 plus 0. So 8 minus 4. Plus, then we have 4 plus 7 plus 9. So this is 7 plus 3 is 10, 10 plus 4 is 14x cube plus minus 5x square plus 8 minus 4 is 4x plus 7 plus 4 is 11 plus 9 is 20. So we get 14x cube plus minus is minus 5x square plus 4x plus 20.